For balancing chemical equations, the first thing you need to know is the law of conservation of mass, that matter cannot be created nor destroyed, only rearranged. And so we show this in the form of a chemical reaction when we do this in chemistry. I'm going to skip on down to the second problem because I already know that the first one is a little bit difficult. Anytime you see two of the same element on one side, that usually means it's going to be a little bit harder. Now, when doing these, I think it's a good idea to always start with the bigger molecules first, and that way you can knock out a lot of the elements all at one time. Here we have lead on the left and we have lead on the right. So there's one lead here, so those are balanced. Here for the nitrate, it says that I have 2 of the nitrate ion, and on the right side there's only 1 of the nitrate ion. So the rule is you can only add numbers in front of the compounds, and you cannot change the subscripts. You can only change the coefficients. That is something that is very important to know, that you can only change the coefficients. You cannot change the subscripts. So in this case, now that I put the 2 here, it changed the number of sodium to 2 on the right side. You have to go back and make sure that you also have 2 sodiums on the left. Once I did that, that changed iodine to 2, and we have 2 on the right side, so now those are balanced. We know we are done with these problems when every element has the same number of atoms on both sides, and that's when the law of conservation of mass applies, that nothing was created nor destroyed, it was only rearranged. And when we say rearranged, we mean that sodium iodide and lead nitrate just switched up who they were with. So it was a double replacement. Okay, let's try the next one here. Now, very often, anytime I see a 3 and a 2 combination, now notice I'm starting with the biggest molecule. Here we have 3 of the bromine and 2 on the right side. I like very often to do the reciprocal, where I would put the 2 here and a 3 here to try to get it where they're, both 6, the lowest number that they can both go into, and that will eliminate a lot of problems. You will use that little trick often whenever you see 2s and 3s. Trying to make them an even number always helps out. Okay, so we have, now that we did that, we have a total of 6 bromine on the left, 6 on the right. We have 2 aluminum on the left, so we're going to add a 2 here. Now that we did that, it changed the fluorine. We have 3 of the subscript, but there's 2 of the coefficients, meaning there's a total of 6 fluorines on the right side. And on the left side, in order to make that a total of 6, we'd have to put the 3 there. Okay? Don't forget that whenever we have something like 3F2, that's the same thing as saying F2, F2, F2. And remember, each one of these says that we have 2 of them. So if we wanted to take it further, it's the same thing as saying that. Okay? So of course we're lazy and we want to make it very simple for ourselves, so we do it like this in chemistry. Okay, moving on to the next example. You have 1 calcium on the left, 1 on the right, so that's good. You have hydroxide. There's 2 of them on the left, but it looks like there's water on the right, and then there's hydrogen here in a different location. That makes it a little bit more tricky, but sometimes you will do something and you'll find that you have to go back and change your answers. I already know that I like even numbers, so when I see that there's this hydrogen here by itself and there's a total of 3 hydrogens on the left side. What I like to do is try to make it even number. So if I were to put a 2 here, that would make it a total of 4 hydrogens on the left. To make it 4 on the right, I would put a 2 there. Now that I did that, we have 2 oxygens on the right. We already have 2 oxygens on the left. We have 2 chlorines on the left, and we have 2 on the right. And calcium, there's 1 on each side, so we are good. Okay, now this next one is a little bit tricky, but it turns out there's a little trick that makes it a lot easier to do this. If you can remember this for anything that is organic, okay, you would take the hydrogen and divide it by 2. So you would divide H by 2. In this case, we have 12 of them. If we divided it by 2, we get 6, okay? If your answer is even, you would put a 1 in front of the organic, okay? If it's odd, you'd put a 2 in front of the organic, okay? So let's do that. We have the 6, which is even, so that means we're going to put a 1 in front. Then you would have to, in this order, so we'll make that first step, second step, third step, you would have to make sure that you balance first the carbons, then the hydrogen, then leave the oxygen for last. Okay, so now I have 5 carbons on the left. I'm going to put a 5 here to make the carbons equal. Next, it would be the hydrogens. I have 12 on the left. In order to have 12 here, I would have to put a 6 in front. Then we have to count the oxygens on the right side and realize they're in 2 different locations. I have 6 oxygens here, and I have 10 here, making it a total of 16 oxygens. And in order to have 16 oxygens here, I would have to put an 8 in front. These can be difficult if you don't know this trick. Let's try one more. We have hydrogen. You would divide it by 2, which is 11. This is an odd number, so you would put a 2 in front of it. Then the carbons would be the first thing that you balance. You have 20 on the left. You'd put a 20 for the right side. Next, you want to balance the hydrogens. You have 44 on the left, so you would put a 22 there to make it 44 hydrogens on both sides. And the last step is to add up all of the oxygens. You have 40 with carbon dioxide. You have 22 here with the water. So that leaves it to be a total of 62 oxygens. And in order for that to be the case on the left side, you would put a 31 there. And that makes it equal on both sides. Okay, let's go back to the very first example and let's try it. Now that we can see that there's oxygen in 2 different locations, but if I made this a total of 4 oxygens on the left, then what would I have to do to the right side in order to have 4 oxygens? Well, I could just do that. And it takes care of carbon as well. And that's how you balance equations. So good luck.